Good morning. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. So I have a question for you. Those of you that go in and listen to the YouTube video, do you listen to this part or do you go past it? No one.
I listen to it.
Oh, I'm thrilled. I'm deeply moved.
Just because I don't want to miss anything at the beginning, though.
You just never know. I might say something important there. All right. So today I've got some questions from people, and then eventually we are going to take a look at section 5.8, part 1. Tomorrow we'll do part 2 in the chapter review. Let's see, tomorrow is Thursday. Friday we'll review. So it looks like we're going to have a test on Monday. I'll revisit that tomorrow, but that looks like that's the plan. And oops, so now let's come down here. And this is actually from section 5.6, which is from a couple days ago, problem number 21. It says, multiply, simplify your answer completely. And what we have is 5.3 AB times the quantity 5AB plus 8A minus 2B. So we're going to distribute. We're going to take 5.3 AB times 5AB. So first of all, let's see, I've got 5.3 times 5, that's 15, what? 26.5 A squared B squared, because you've got it A squared and B squared, okay? Then 5.3 AB times 8A, 5.3 times 8, 24, carry the 2, 40. So we get what? Plus 42.4 A squared B. And then finally, 5.3 AB times minus 2B. 5.3 times 2 is what? 10.6, but it's going to be minus 10.6 AB squared. So there's the final answer for that problem. Any questions from anybody on that one? All right, let's see here. Now we need to go to 47, 75. Okay, this is number 5.7, number 11. Okay. All right. This is 5.7, number 11. It says, find the product. Oh, I see what the person did wrong, and it's an easy mistake to make. You know what? I'm going to just show you the actual web-assigned problem. I'm not going to do it. I'm going to just have you look at it, and I think you'll see. So here it is, number 11. The correct answer, the variable is a D, and they used an A, but if you look really closely there, it's hard to tell. That's the kind of problem where if you missed that on a test, I'd give you full credit for it. But anyway, so to the student that did this problem, you were correct. It's just that you just had the wrong variable. It's really hard to see that that's a D to the 4th power there. Okay, so yeah. All right. Anyway, otherwise the answer would be correct. So you just need to change your variable. Okay. That was a tough one to miss. All right. So now we are going to go to section 5.8, and this is part 1. The reason I've got it divided up into 2 parts is because this section involves dividing polynomials. The first part isn't too tough. The second part gets a bit more complicated. So I find that 2 days works a lot better with this information. Okay. Now, the first part of this is somewhat of a review of the first part of chapter 5, which again, we didn't cover this quarter. It would have been covered in Math 85 or perhaps in a beginning algebra class somewhere else. But I want to review some basic rules, okay? We've already talked about the fact that if you're multiplying two powers with the same base, so like a to the m power times a to the n power, you add the exponents. So if we had x to the 4th power times x to the 5th power, that would be x to the 4 plus 5 power, or x to the 9th power. And we could go straight here. We don't need to do that, but just showing how it works, okay? So if you're multiplying two powers with the same base, you add the exponents. For instance, when we had like x plus 3 times x minus 2, and we FOILed x times x, that's like x to the 1 times x to the 1, which is x squared, okay? All right, now, another rule that applies, if you are dividing two powers with the same base, instead of adding the exponents, you subtract the exponents. Well, addition is commutative. So we can add two exponents in either order and it doesn't matter. But when we subtract, we've got to subtract the bottom exponent from the top exponent. So let's say I had x to the 5th power over x squared. That would be x to the 5 minus 2 power, or x cubed. And this is all in the numerator, okay? This part here. We don't need to write it over 1, but just to imply it is in the numerator, not the denominator, all right? Now, let's say we've got something like this. We've got x to the 5th over x to the 5th. Well, that would be x to the 0 power. But wouldn't a number divided by itself also equal 1? And that brings us to a number raised to the 0 power equals 1. So that's another review from, this is from section 5.2. So if you want to do a more extensive review, you could go into either your textbook or your ebook online and look at that section 5.2, or come to my office hour and ask me questions if you need more than what I'm going to be doing here. All right. Another thing that comes up is you might have this case where the power in the numerator is smaller than the power in the denominator. So you end up getting a base, the x, to a negative power. But if we do this same problem and we write it out the long way, 3 factors of x over 5 factors of x, and then we reduce this down, we get 1 over x squared, which means x to the negative 2 equals 1 over x to the positive 2 power. So what we get is this rule. If you have a base raised to a negative exponent, that's equal to 1 over the base raised to a positive exponent. Okay? So this rule in combination with this rule in combination with this rule is going to help us get through this next part. So here we go. All right. So let's say I've got a to the 12th power over a to the 8th power. It says divide the monomials. Remember that a monomial has one term. So a to the 12th power is a monomial. A to the 8th power is a monomial. So we're dividing a monomial by a monomial. Since the bases are the same, this would be a to the 12 minus 8 power, or a to the 4th power. Any questions on that? All right. Let's say we've got 22b to the 9th power divided by 6b to the 6th power. Well, the coefficients, the 22 over 6, they're both even, so I could reduce those down to 11 over 3. Okay, dividing the top and the bottom both by 2. B to the 9th over b to the 6th is b to the 3rd power. So we end up with 11 thirds b cubed. All right. Again, any questions on that problem? Okay. 16y cubed over y to the fourth power. Well, in the numerator, I'm going to get 16, and then this would be y to the 3 minus 4 power. So that would be 16y to the negative 1 power, would be 16 times 1 over y to the positive 1 power, which is 16 over y. In other words, this, you're going to get rid of 3 factors of y in the numerator and 3 factors of y in the denominator. So you're going to have 1 factor of y left in the denominator. Okay. And also keep in mind that y is the same thing as y to the 1 power. I'm not sure, but I suspect that in WebAssign, if there's an exponent of a 1, you don't want to put it there, since it doesn't like a 1 as a coefficient, even though it's implied. Questions there?
Can you do another one? like that?
Absolutely. You betcha. Okay. How about this one? 3y cubed z over 18y z to the 6th power. So we're going to look at this in 3 separate pieces. We're going to look at that, and then that, and then that. Okay. The 3 over 18, I could reduce that down to 1 over 6. Okay. The y cubed over y, there's an implied 1 there, so that's y to the 3 minus 1, or y squared. The z over z to the 6th power, there's an implied 1 exponent on the z. Z is equal to z to the 1 power. So this would be z to the 1 minus 6, which is z to the negative 5 power. Now, and I guess I didn't mention this before, but typically you want your final answer to have positive exponents if possible. Okay. So what I'm going to do now, I'm going to take this and move it downstairs, do the reciprocal, and change it to a positive 5 exponent. All right. Now, I don't technically need the 1 now, so I could write y squared over 6z to the 5th. Or I could write it this way, 1/6, and then like that. Probably, let's see here. My guess would be that this would be the preferred way of writing it. Okay. But that implied that 1 doesn't need to be written there, because 1 times something is the same thing as the something. 1 pen, pen, same thing. You want another one of those, or are you okay?
No, I'm good now.
All right.
Thank you.
You're welcome. Okay, now we're going to expand our horizons just a little bit. And we're going to have a polynomial divided by a monomial. So the numerator will have more than 1 term, but the denominator will still be a monomial. So for instance, 6x plus 3 divided by 3. What we're going to do in this case, when the divisor, the denominator of the fraction, is a monomial, we're going to take each term in the numerator and divide it by the denominator. So we're going to split it up into separate fractions. Then we're going to go back and simplify each fraction if possible. So 6 over 3 would be 2. So this is going to be 2x. And 3 over 3 is 1. So your final answer, 2x plus 1. What you don't want to do is do something like that, or like that. You can't do that because these are terms in the numerator. You can only reduce if everything in the numerator is a factor of the numerator, and everything in the denominator is a factor of the denominator. So we've got to separate out the separate terms and then reduce each one separately. You can't do this or this. Doesn't work that way. Okay, think of it this way. Let's just put numbers in there. If I have 7 times 3 over 3, I could reduce that down to 7, right? But what if I had 7 plus 3 over 3? Can I do that? Is that a correct move? No. You'd have to write it as, let's see, you'd go, it's 10 over 3 and then take it from there. So you can't do that. If they're factors, you can reduce. If they're terms, you can't. So again, back to this idea where we have to split things up. So let's take a look at some more of those. Let's see, 8x plus 4 divided by 4. A polynomial divided by a monomial. So we're going to take each term of the numerator divided by the denominator. Then we go back and simplify each separate fraction. 8 over 4 is 2, so I get 2x plus 1. Okay. Let's see here. This says b squared plus b cubed minus b to the 4th power all over b to the 4th power. So again, a polynomial divided by a monomial. Each term in the numerator divided by the denominator. Okay. And I want my answer to have positive exponents, not negative exponents. Now, let's see here. Let's take a look at this situation. B squared over b to the 4th is b to the 2 minus 4 is b to the negative 2 power is 1 over b squared. All right, with that, we're getting rid of 2 factors of b in the numerator and 2 factors of b in the denominator. So I've got a 1 on top, b squared on the bottom. Next fraction, b cubed over b to the 4th is b to the 3 minus 4, which is b to the negative 1, which is 1 over b to the 1, or just 1 over b. And finally, b to the 4th over b to the 4th is 1, or that's b to the 0, which is still equal to 1. So I've got minus 1. And there's my final answer. Any questions on that one? Okay, let's take a look at another example. Are we good to go on? I guess. Okay. 4x to the 14th power. If you need to stop me, say so. I'm in no hurry. I'm not going anywhere. Well, that's for sure. 36x to the 8th all over 36x to the 12th power. A polynomial divided by a monomial, we're going to get 4x to the 14th over 36x to the 12th minus 36x to the 8th over 36x to the 12th. The first fraction, 4x to the 14th over 36x to the 12th. 4 over 36 reduces down to 1 over 9. And x to the 14th over x to the 12th would be x squared. Okay, so we get 1/9 x squared, or you could write it as x squared over 9, either way. Okay. Going on, we've got minus, let's see, 36x to the 8th over 36x to the 12th. Their 36 is reduced to 1 over 1. So then I've got x to the 8 minus 12, which is x to the negative 4, which is 1 over x to the 4. So I could write the answer like this or like that. Any questions there? Okay, let's see here. Let's take a look at this one. 16b to the 10th power plus 4b to the 6th power minus 20b to the 4th power all over 4b to the 2nd power. So again, a polynomial divided by a monomial. Each term of the numerator divided by the denominator. Okay, so let's go through these one at a time. The first one, 16 over 4 is 4 over 1. B to the 10th over b squared would be b to the 8th. So this would be 4b to the 8th power. Plus, taking a look at this one, 4 over 4 reduces to 1 over 1. B to the 6th over b to the 2nd is b to the 4th. And 1b to the 4th, we can just write b to the 4th. And finally, the last term, minus 20 over 4 is 5 over 1. B to the 4th over b squared is b squared. So minus 5b squared. So there's the final answer. All righty. Any questions on this? A polynomial divided by a monomial. Okay, let's get out of the shallow end and wander into the deep end a little bit here. First of all, I want to review long division in terms of arithmetic. Let's say we've got, 847 divided by 23. Okay, so we're going to put 23 on the outside and 847 on the inside. So then the first question we ask is, does 23 go into 8? And it doesn't. Does 23 go into 84? Yes, it does. How many times? Let's see. It goes in once, twice, 3, 4. It doesn't go in 4 times. It goes in 3 times. So we put a 3 up here. What do we do next? Anybody? Do you not remember, or you just don't want to speak today? Well, okay. You take 3 times the 23. So you get 69. What do you do next?
We subtract them, right?
Actually, no, you draw a line.
Oh.
And then you subtract them. Yes, sorry, I'm just mean that way. So 84 minus 69, we're going to borrow and carry, and that's a 5 and a 1. Now, since this number is smaller than that, we know we did it correctly. Okay. So then we're going to bring down the next number and start over. Let's see, 23 goes into 157. Oh, let's see, 5, 6, 7. I'm thinking 6 times. Let's see, 23 times 6 is 18, 138. Let's see, subtracting, that's a 9. Yeah, okay. Now, way back in like 4th or 5th grade, when you were doing arithmetic, and the first way you might have learned this is you'd go 36, and then you put an R for remainder, and you'd write R19. So the answer would be 36, remainder 19. Okay, then later in life, let's see here, this is a 69 and a 157 and a 138 and a 19. Then you'd get to where you'd write the answer, and then the remainder would be written as a fraction. So it'd be 36 and 19/23. So the remainder over the divisor, okay? That's the form we're going to be using today with polynomial division. Okay, now, let's say we have the following situation. It says, divide x squared plus 8x plus 12 by x plus 2. Or another way we could write that is we could say x squared plus 8x plus 12 divided by x plus 2. The long division form of writing that would look like this. We'd have x plus 2 outside and x squared plus 8x plus 12 inside. Now, up till now, this morning, we were dividing first a monomial by a monomial, then a polynomial by a monomial. That's when we split it up into separate terms. But when we're doing a polynomial by a polynomial, that's when we use this long division form here, okay? All right. Now, here's the process. First of all, we want the dividend, that's the number inside, to be in descending powers, and it is x squared, x, no x at all. We want the divisor, the number outside, to be in descending powers, x plus no x at all. That is the constant, okay? So the inside number and the outside number are both in descending powers. Then what we're going to do, we're going to focus on the leading term inside and the leading term outside. So we're not worried about the whole polynomial, just the leading terms. We're going to take the leading term inside divided by the leading term outside. So the x squared divided by the x. What is x squared divided by x? Anyone?
It's just x.
It's
right?
just x. Good. So we're going to take that and we're going to put it right up here in the column where the x's go. The next thing we're going to do, we're going to take this times all of that. So we're going to take x times x plus 2, which is x squared plus 2x. And we're going to write that down below here, draw a line, and then we're going to subtract that quantity from what's up above. Now, let's go back here for a minute. When I subtracted this, I didn't need to put parentheses around it because that's all one number. But here, we've got two terms. So I need ultimately to distribute that subtraction sign to both of those terms, okay? So that's why I put parentheses around it, okay? Now, what I'm going to do next is I'm going to change the subtraction into addition of the opposite. In effect, I'm going to distribute that subtraction sign. So subtracting x squared plus 2x becomes adding negative x squared, and then this plus becomes a minus 2x. So distributing the subtraction changes it to addition of the opposite. Everything inside the parentheses gets the opposite sign. Now, adding up the terms, 8x plus negative 2x is 6x. X squared plus negative x squared is 0x squared, which I don't really need to put anything there. I just bring down the 6x. Okay, how are we doing? Now we start all over. Oh, we're going to bring down the next term. And then we're going to take the leading term inside divided by the leading term outside. So we're going to take 6x divided by x. What is 6x divided by x? 6. And it's a positive 6, so I'm going to write plus 6. Okay, so then I'm going to take this times all of that. So 6 times x plus 2 is 6x plus 12, which I'm going to write here. Draw a line, subtract that whole quantity from what's up above. Distribute the subtraction, change it to addition of the opposite. Adding up each column, 0, 0, so I have no remainder. So my answer is x plus 6. So x squared plus 8x plus 12 divided by x plus 2 equals x plus 6. Any questions there? You're all thinking, I got out of bed for this? Okay. Let's check our work. Before we do that, what's 15 divided by 3? Well, it's 5. How do you check your work? Is 3 times 5 equal to 15? Yes, it is. So if this divided by that equals that, this times that should equal that. Let's see. X plus 2 times x plus 6 is x squared plus 6x plus 2x plus 12, which is x squared plus 8x plus 12. Bingo, it checks. Okay. All right. Let's take a look at some more of these situations. I have, let's see here, x squared minus 12x plus 32 divided by x minus 4. So writing it in long division form, x minus 4 on the outside, x squared minus 12x plus 32 on the inside. So we're going to focus on the leading term inside divided by the leading term outside. And again, I want to point out that inside and outside, both polynomials are in descending powers. That's important. So let's see. X squared divided by x would be x. So that's going to go up here. Then we're going to take x times x minus 4. So x times x minus 4, which is x squared minus 4x. And that's going to go right there. We're going to draw a line and subtract that quantity from what's up above. We're going to distribute the subtraction sign and change it to, here, we'll make it a different color, addition of the opposite. So now, negative 12x plus 4x would be negative 8x, and x squared plus negative x squared would be 0. So again, I can just write negative 8x. Any questions? Okay, bring down the next term and start all over. We're going to focus on the leading term divided by the leading term. So we've got negative 8x divided by x, which is negative 8. So up here, I'm going to put a minus 8. Then I'm going to take negative 8 times x minus 4, which is negative 8x plus 32. I'm going to write that here. I'm going to subtract that quantity from what's up above. I'm going to change it to addition of the opposite. So I get 32 plus negative 32 is 0. Negative 8x plus 8x is also 0. So again, no remainder. So my answer is x minus 8.
So, Mr. Mayo, what happens if, say, in the final equation, you didn't multiply the x minus 4? Or, I'm sorry, I don't know how to say this.
That's okay. You're doing
What
fine.
if the 4 was a 3 or a 2? You know, something that wouldn't make 8 into 32. What would
So
happen then?
this is what I think you're asking. What if there's a remainder?
Something like that, yeah.
Because in other words, what if these don't come out exact?
Yeah.
That's
Yeah.
what we're going to look at next. So here we go. Let's say we've got 2x squared plus 5x plus 2 all over 2x plus 3. So again, a polynomial divided by a polynomial. 2x plus 3 is going to go on the outside. 2x squared plus 5x plus 2 is going to go on the inside. All right. We're going to take the leading term inside divided by the leading term outside. So we've got 2x squared divided by 2x, which again reduces down to just x. So we'll put x up here in the x column. Okay. Then we're going to take x times 2x plus 3, and we're going to get 2x squared plus 3x. So 2x squared plus 3x. Okay. We're going to subtract that quantity from what's up above. We'll distribute the subtraction sign or change it to addition of the opposite. 5x minus 3x is 2x. 2x squared plus negative 2x squared is 0. So I get 2x. Then I'm going to bring down the next term and start all over. I'm going to divide the inside leading term by the outside leading term. 2x divided by 2x is a plus 1. So then I'm going to take 1 times 2x plus 3, which is just 2x plus 3. Okay. I'm going to subtract that quantity from, oh, that's a long subtraction sign there, from what's up above. Going to change it to addition of the opposite. 2 plus negative 3 is negative 1. 2x plus negative 2x is 0. So now I have a remainder. So I'm going to write my remainder as a fraction. It's going to be that over the divisor. Now, I'm going to write x plus 1, which I already have, plus negative 1 over 2x plus 3. Okay. Let's see if I can erase that and make this a little nicer. Now, so this is x plus 1 plus the answer. Some authors would write it this way. They'll write, if it's a negative, they'll put a subtraction sign out here. This particular author for this textbook always writes plus the remainder. So if this is a positive 1, you just write plus 1 over 2x plus 3. If it's a negative 1, you'd write plus negative 1 over 2x plus 3. Okay. Let's do another one. But before we do, any questions about that?
No, thank you.
Okay, let's take a look at this one. We've got 2x plus 1 on the outside and 4x squared plus 6x minus 1 on the inside. So again, we're going to focus on the leading term divided by the leading term. 4x squared divided by 2x is 2x. 2x times 2x plus 1 is 4x squared plus 2x. 4x squared plus 2x. We're going to subtract that quantity from what's up above. We're going to distribute the subtraction sign or change it into addition of the opposite. 4x squared plus negative 4x squared is 0. 6x plus negative 2x is 4x. Bring down the next term and start the process over. 4x divided by 2x is 2, so plus 2. Then we're going to take 2 times the quantity 2x plus 1, which is 4x plus 2. We're going to write that down there. We're going to draw a line and subtract that from what's up above. We'll distribute, changing subtraction to addition of the opposite. 4x plus negative 4x is 0. Negative 1 plus negative 2 is negative 3. So my remainder is negative 3. So I'm going to write 2x plus 2 plus negative 3 over 2x plus 1. Any questions on that one? Okay, let's see here. Let's take a look at this one. 2x minus 7 divided into negative x minus 21 plus 2x squared. All right, what is wrong with this problem? What do I need to fix before I go on?
It's not in descending order what you're subtracting.
Correct. So I need 2x minus 7 outside, inside 2x squared minus x minus 21. So inside was not in descending power, so we need to put it there. All right. So now we're going to take the leading term inside divided by the leading term outside. 2x squared divided by 2x is x. X times 2x minus 7 is 2x squared minus 7x. We're going to write that here, 2x squared minus 7x. We're going to subtract that quantity from what's up above, change addition or subtraction to addition of the opposite. I get 0 and I get 6x minus 21. 6x divided by 2x is a plus 3. 3 times 2x minus 7 is 6x minus 21, which I write over here. Subtract that from what's up above, change it to addition of the opposite, and we get 0 remainder. So this would just be x plus 3 with no remainder. But again, it's important that we have the inside dividend and the outside divisor in descending powers. Okay, let's see. We've got a few more minutes. Let's go back to some things we did earlier today. Let's say we've got a polynomial. This is an f to the 4th power plus 16 over a monomial. Okay. In that case, recall, whoops, let's see if I can, I guess I can fix that. We've got each term of the numerator divided by the denominator. Negative 40 over 8 is negative 5. F to the 4th over f to the 3rd is f to the 1 power, so negative 5f, plus 16 over 8 is 2 over 1, 2 over f cubed. Since f cubed on the bottom has a positive exponent, we'll just leave it where it is. So your answer would be that, okay? A polynomial divided by a monomial, you use this form, not the long division form. And then let's go back even further in today's lesson. Let's say we've got a monomial divided by a monomial. Okay, let's see. Well, positive divided by negative is going to be negative. I know that. Let's see, what goes in to 112 and also goes into 42? I know 2 goes in. This would be what, 56 over 21? Oh, what goes into 56 and also goes into 21?
Would that be 7?
It would be. This would be an 8 and a 3, so I get negative 8/3. Okay. Now, how about u over u cubed? That would be u to the 1 minus 3, which is u to the negative 2, which is 1 over u squared, so u squared on the bottom. Or you could think of, get rid of 1u on top and 1u on the bottom, and you got 2 u's on the bottom. How about z to the 4th over z to the 8th? That would be z to the 4 minus 8, which is z to the negative 4, or 1 over z to the 4th. So that's going to be down below as well. So we get negative 8 over 3 u squared z to the 4th, or you could write negative 8 over 3 u squared z to the 4th. So you could apply that negative sign to the entire numerator or just out in front of the entire fraction. Okay. Any questions on that? All right, so tonight you're going to do the first part of section 5.8. Once again, I'll be back at 1:15 with an office hour if you have any questions. And I'm going to stop the recording.